this video, we're going to drill into the latest best practices for implementing OpenID Connect in a single page app. And we're also going to show you how to run an end-to-end solution. Building apps for the browser is challenging due to the potential for security and usability problems such as dropped cookies. We're going to show that a clean separation of web and API concerns is the best way to deal with these issues, and it will give you the apps with best capabilities. So let's have a look at the key behavior. So the single page app will use an API-driven OpenID Connect solution where you plug in a backend for Frontend API. So you don't need to develop this API yourself. It will be provided by Curity. The result will be that the browser uses the latest secure cookies that the modern browsers support. These are same site equals strict cookies, and the browser sends these cookies in API requests. So this will be done in a manner that is transparent to your APIs, which will still work with JOTs. The result will be simple code in the single page app, minimal usability problems, and in addition, there'll be no restrictions on where you deploy the single page app. You can deploy it to a content delivery network if you want. So let's have a look at the overall solution. And the key thing to understand is that although there's quite a few moving parts here, there's only 3 areas that you need to develop yourself. So obviously you need to develop the single page app. You also need to develop your microservices or APIs that receive JOTs. And of course you need to deliver your web static content somewhere, such as from a content delivery network. So we're going to show how to get this end-to-end solution working on a development computer, and this will result in good browser security and also a good all-round architecture that is easy to scale to multiple apps. The end-to-end demo is based on a GitHub repository at github.com curity.io. If you find the one called Web OWls via BFF, this provides step-by-step instructions on how to run the end-to-end solution. So we're going to do that. First, it's worth mentioning prerequisites. So what I've done here is the single page app will actually run on this test domain called www.example.com. And an important point to understand is that the BFF API needs to run on a related domain. It needs to be in the same site as the web origin. So here we're using api.example.com. We're also running the Curity Identity Server on this URL here. The other thing you'll need is a license file for the Curity Identity Server, which we'll look at shortly. So let's do what it says in the README. I'm going to build up the code by move to the code folder and build it up like this. While we do that, I'm going to take you through a little bit of code. So first of all, let's look at the API. So the API just uses a library called express OWls JOT, and it says secure my data using this library. And there's only a single API endpoint, which is a post, and it returns a hard-coded string. So it's a very standard API, very simple code. You don't need to change anything in your APIs. In the single page app, this is a very basic React.js app, but the view code is very simple, and the only interesting thing about the sample really are these 2 classes, OWls client for doing the OWls work and API client for calling APIs afterwards. So let's have a brief look at this, and I'm not going to go into any details, but as you can see, it's pretty much all one-liners. So this is very much an API-driven solution that keeps the SPA nice and simple. So that's all finished building. What I'm going to do next is I'm going to move to the deployment folder, and I'm going to kick off the deployment script. So in the deployment folder, one thing that you'll need to do when you run the solution yourself is to copy in a license file. You can download one of these from the developer portal as it says in the README. So I'm going to kick that off. And a couple of things worth noticing are that during the build and deploy stages, it downloads some of the Curity components. We'll look at these in the final section of the video. What we're doing when we deploy is we're actually running a Docker Compose network. So the web host is being deployed. So the web host, let's have a quick look at this. This is just This delivers web static content, and I'm just using the Node.js Express static feature here. I'm also setting some content security policy, since it's recommended to set security headers in a browser-based app. Going back to the Docker Compose file, as you can see, we're running the example API and the BFF API that we've downloaded up here. These are also being deployed. And what's interesting is that the APIs themselves are not exposed from the cluster. Instead, they're hosted behind a reverse proxy. We'll look at some of the details of that in the final section of the video. And finally, we're deploying a standalone instance of Security Identity Server and a database with a fixed user called demo user password1, which we'll use in a second. Right, so all of our systems are up and running. What we're going to do is we're going to test this, and let's use a Safari browser, which is, often a little bit fussy about cookies and dropped cookies and usability problems like that. So what we're going to do is we're going to run the single page app. And it's a very basic single page app. It just presents an unauthenticated view first of all. If I click this, then there's a user called demo user password1. Sign in as that user. And let's go through these operations. So sometimes in a single page app in the past, you may have received an ID token. In the BFF setup, what we have to do is we have to call the API, which the API will then give us the user information, and we will then render the username or whatever in the API. We can test API calls all the way through using same-site cookies here, and the cookie gets translated to a JOT, and again we'll look at that in the next part of the video. We can open a new browser tab, and multi-tab browsing tends to be a problem area sometimes in some older SPA solutions. So what we'll see here is there's no problems with this. We can do things on multiple tabs, and we can even sign out from all tabs together if we want to. So usability is good. There's no issues around dropped cookies or anything. And so we've shown a completed solution, and the only thing left to do really is to drill a bit more into how the cookies work and how they're translated into tokens and what these components do. So we'll do that in the final section of the video. So next we're going to give you an overview of some of the internals so that you've got a rough understanding of how the solution works. So let's go through the settings. So in the deployment folder, every component that we deploy in the Docker Compose network has a config file. At the time of writing the BFF API, just uses an object. Though we're likely to change this to environment variables by the time this video is released. But let's go through the settings. So what's interesting is that the single page app now has access to a client secret. Because it's being routed via an API, the API can attach a client secret to request to get tokens. So this is one way of improving security. The cookies issued all use an they're all encrypted using AES-256 encryption, and the encryption key is only known to the server. You can give the cookies issued your own prefix if you want, depending on your company or product name. The cookies options are HTTP only, meaning that JavaScript code cannot access them. They use same site equals strict, which prevents a lot of cross-site request forgery attacks. In a real SSL setup, they would use secure true. And interestingly, the domain is the API subdomain here. And what's interesting is that the secure cookies are not actually needed on web requests. If we look at our web origin, the actual single page app's web origin is www.example.com, but the cookies only need to have a domain of api.example.com. We could, if we wanted, send the cookie on web requests as well by setting the domain to this value, but by default, not needing cookies on web requests can be quite a good thing in terms of usability, because these dropped cookie issues never affect you during navigation now. So one possible issue is logging in and then returning to your app via an email link, that will drop same site equals strict cookies, but it doesn't affect us because during navigation we're only requesting web content. So the secure cookies are only used on AJAX requests. They're never used on web static content requests. So that's quite a good point to understand, and that's one of the reasons why separating the web and API concerns gives you better usability. So that's the information about the secure cookies. We actually issue multiple secure cookies, and the cookies contain the OAuth tokens. So for example, there's a cookie for the refresh token, the access token, and the ID token, but the browser can never access them because they're encrypted, and JavaScript code never has access to the cookies anyway. So this is all good from a browser viewpoint. So really that's the same site cookie stuff and the BFF API described. If you want to, you can drill into the code here to look at some of the details and learn more. Next, let's look at the API routing. So this is probably one of the interesting parts. So what we're doing, if you're familiar with Curity and our recommendations around security, you'll already be aware of the Phantom Token plugin, which introspects an opaque reference token, retrieves a JOT, optionally issues scope checks, and then forwards the JOT to APIs. So the only thing new here really is a new component in the reverse proxy called the BFF token plugin. And all that this does really is it decrypts the cookie, possibly makes some additional CSRF checks according to the OWASP best practice, and then when it decrypts the cookie, it will receive the reference token, and the flow can continue in the normal way. So it may look complicated, but it's really just something you configure when you deploy the system. Let's have a look at how that looks. So we're using a reverse proxy. We're actually using Kong open source. So both the BFF API and the example API, the business API, are hosted behind the reverse proxy. For the BFF API, we just route everything straight through and there's no special logic. But for your own microservices, there will be some additional logic. So if you're following Curity guidance, you'll already be using the Phantom Token plugin to swap the confidential internet tokens for JOTs containing rich claims used by APIs. What you now need to do is you need to put this BFF token plugin before the Phantom Token plugin and give the BFF token plugin the encryption key. And if we actually look in the plugin, this is implemented using a very simple Lua script. So there's a handler class and there's an access class, and this is all pretty easy to follow this code. There's not much of it. It just uses AES-256 to decrypt the cookie, pulls out the reference token, and adds it to the authorization header, and then the next plugin does its existing job. So quite a few moving parts, but the Docker Compose file and the reverse proxy configuration show you how all of this fits together. If we go back to the reverse proxy entry in Docker Compose, we see that we're exposing the API domain over port 3000, where we are copying in two plugins, the BFF token plugin and the Phantom token plugin, and we are copying in that Kong configuration file. We're then just telling Kong that these are the two plugins it needs to load, and that's it really, and that's the job done. So yet again, this shows the type of thing you can do in a reverse proxy, the extra level of indirection that a reverse proxy gives you. So that's it. We've been through the whole solution. There's far more detailed write-ups on the Curity guide, so feel free to consult those for further information. And of course, you can also look at the source code that I've shown you. So thank you very much for listening, and good luck with your SPAs.